Hello, Trig. The word of the day today will be the word determinants. Before we get to that word, just a little bit of background information. For a matrix, when I'm talking about the rows, I'm talking about the parts that go across. So 1, 2, 3 is a row, 4, 5, 6 is a row. If I'm talking about the columns, I'm talking about the stacks. So 1, 4 is a column, 2, 5 is a column, 3, 6 is a column. The shapes of these are always the rows by the columns. So this matrix is a 2 by 3 shaped matrix because there's 2 rows and there's 3 columns. If these numbers were equal, the rows and the columns were equal, that would be called a square matrix, and every matrix we're going to look at for the rest of the day today is going to be a square matrix. Every square matrix has a number associated with it, and that's called its determinant. Instead of writing out in every problem the words, find the determinant of this matrix, they're going to write it to look like it's absolute value bars. These have nothing to do with absolute value bars. In matrix world, when you see something that looks like absolute value bars, that's an abbreviation for them writing the determinant. So when you see this in bars, that's us doing the determinant. To do the math on the determinant, we're going to multiply these two numbers in these two positions. That's called the main diagonal. Take A times D for the main diagonal. Always minus the numbers on the other diagonal, which doesn't have a name because it's not the main diagonal. B times C are the other diagonal numbers. Sometimes you get a little minus makes plus kind of thing happening, but it's always main diagonals numbers multiplied minus the other numbers multiplied for a 2 by 2. So for this, I multiply those on the main diagonal, that's -3. I always think subtraction. I multiply the numbers on the other diagonal, that's 30. We math that, and it's -33, and that's it. I promised you an easier day today, and I think you would agree so far I'm delivering on that promise. For this, we multiply the main diagonal, that's -21. Always think subtracting. We multiply the other numbers on the other diagonal as a normal 20. We math that up, and that's -41. There is no such thing as a hard 2 by 2. The worst I could do is maybe if I made that a negative, then we're subtracting a negative. Minus makes plus. -1, I mean, I guess that could happen, but that's about it. About half the homework will be 2 by 2s. The back half of the homework will be 3 by 3s, which will be a little more work. To do the 3 by 3s, what we're going to try to do is make ourselves a series of 2 by 2s. We're going to pick any row or any column as our basis to use, and you're looking for the easiest numbers possible. 0 is always the champ of all. 1 would be your runner-up. So if you see a row or column with 1s and 0s, I would use that row or column. It doesn't matter which one you pick, but there's usually a way that'll make your math easiest. We'll also need to use this little diagram, which I'll explain in a second, but not quite yet. So if I were going to do this problem, I don't think I'd use the 4, 8, 1, because I like the 1, but I don't like the 4 and the 8. 5, 1, and 1 I like better. But this, with 2 1s and a 0, I'm liking that a lot. I'm going to check this way also for a trio of numbers. Triple 1s isn't bad, but if you see a 0, you want to involve the 0. So I'd like to use -1 with a 2 by 2 friend that I'll figure out in a second. 0 with a 2 by 2 friend I'll figure out in a second. And a 1 with a 2 by 2 friend that I'll figure out in a second. Okay. Let me go back to this diagram. I worked off of that grouping. -1 is going to own a space, 0 will own a space, 1 will own a space. -1 is in the position that I titled with a plus. The plus means keep the sign the way it is. The 0 came from the position that has a minus. That means we'd have to subtract the result of this. The 1 came from a position with a plus, so that means I'm going to add that on, keeping its sign. Each of these numbers is going to have a 2 by 2 friend to go with it. So with -1 lives in this column, and it lives in this row. If I cover those up, I'm going to be left with 4 other numbers that I'm going to write down. 0 lives in this column and this row. If I cover those up, I have 4 numbers that I'm going to write down, -5, -1, 4, and 1. 1 lives in this column and this row. I'll cover them up, and I'll write down those other numbers. So -1 is going to multiply whatever I get for an answer from this, doing my 2 by 2 trick from a second ago. Main diagonal 1 minus -8. 1 minus -8 is 1 plus 8, that's 9. 0 is going to multiply this answer, but who even cares? Because 0 times anything is 0, so don't even do that math. +1 wants to multiply the answer from this zone. -40 minus 4 is -44. So this is -9, that's -44, grand total, -53. I'll do another one. So on this, I don't like that column because that has 3 numbers. That has 2 numbers. That only has 1 number, so I'm liking this a lot. This has 3 numbers. This has 2 numbers. This also has 1 number, so I'm liking that a lot. And I like -5 a little better than -6. So I'm going to do -5 owning an area. And I'm not even going to bother writing down the zeros owning areas, because as we just saw, when you get zeros involved, they just kill that area off anyway. So all I need to do is -5 times its 2 by 2 friend, which I find by covering -5's row, covering -5's column, and I write down the numbers that aren't covered. I do the math on this like I did over there, multiply the main diagonal to get -12, minus 0. Anything minus 0 is itself, so this is just -12. -12 times -5 is 60. If I go to do this last one, I don't have any zeros in this, so I'm going to just have to do this the long way. Maybe -2, 1, and 4. I don't know. 2, 1, -3. It's about the same too, but I just need any row or any column. It doesn't matter which one. When I did it on my paper, let me see what I did over here. Looks like when I did the paper of notes, I used the 2, 4, 3 group. Just depends on your moment at the time. It doesn't matter. My answer on the paper when I did the 2, 4, 3 group is going to work out to be the exact same as the answer on the board when I picked a different group. -2 is in a position, though, that I'll switch its sign. 1 is in a position to add or keep the sign. 4 is in a position to switch the sign. When I'm working from this row, this column, that's going to leave me the 2, 2, 3, 3 group. When I work the 1 row column, that's a 3, 2, 4, 3 group. When I work 4's zone, that's the 3, 2, 4, -3. So main diagonal 6 minus -6 is 12. 2 times 12 is 24. 9 minus 8 is 1. 1 times 1 is 1. Main diagonal -9 minus 8 is -17. -4 times -17 is +68. Add that all up, that's 93. Paper doing it the other way says also 93, so it doesn't matter which group of three numbers you pick. They just have to be in the same column or the same row. It doesn't matter. The last tiny little bit of homework will give you a 2x2 matrix to do the determinant, like 3x minus 5. Main diagonal is 3x minus the other diagonal is 5. But then they'll have that equaling something, like it equals 7. And then you just need to have an algebra 1 flashback and do some opposites. Add the 5, divide the 3. There will be just like equations for you to solve at the very end of that homework page, which is 191. So the first 8 are 2x2s. Multiply the main diagonal minus the other numbers from the other diagonal. 15 to 20 are 3x3s. Pick any row or column. Use that as a basis to pick a bunch of 2x2s. Just don't forget about the signs switching for certain positions of numbers. 27 to 29, they're back to 2x2s, but they have like x's in them. And then the last three, 30 to 32, there's x's in them, and you're going to have like an equation to solve once you make the determinant. If you need more help, email me. That's it for now.